So today I'm going to talk about introduction, objective, project overall. A hydrograph is a graphical tool that shows the relationship between rainfall, river discharge, and water levels over time. It tracks our watershed response to precipitation, with rainfall being the initial input that influences water flows in rivers. Hydrographs help in understanding river behavior, flood risk, and water resource management by analyzing the timing of peak flows and overall flow patterns. So our objective is to investigate the rainfall and water level for selected stations and rivers, to determine and plot the unit hydrograph for selected stations and river, and lastly to determine the peak flow.
Assalamualaikum warahmatullahi wabarakatuh. We from Group 9 will explain and elaborate on item 6. Before making the calculation to get the discharge value, there are a few things that need to be taken into account first. After choosing one month that is the highest rainfall rate, data from the water level is needed to make the calculation. Our group has chosen November in 2024 in this project. The data can be found on the Hydrology website. Based on observations, we have chosen 3 days with the highest water level in November, which are on November 19, 26 and 29. To get the discharge value for each hourly interval for the 3 days, there are several values that need to be calculated first. First of all, find the value of slope S. The value of S can be obtained from Google Earth Pro by using the formula S equal to 36 minus 23 over 15,255.91 feet times 100. The answer will be 0.085. Then, we get the value of width B from Google Earth Pro, which is 123.8 meters. The coefficient value is 0.05. After that, we record the water level value obtained from the Hydrology website. Next, calculate the area value by using the formula of width multiplied by water level in square meter units. The value of the perimeter can be obtained by using the formula width plus 2y, that is water level in unit meters. Then, calculate the value of the hydraulic radius R using the area formula A over perimeter in meter units. After that, velocity can be obtained by using the main equation, that is V equal to 1 over n times R to the power of 2 over 3 times S to the power 1 over 2. All values to obtain the volume value has been calculated, namely coefficient n, radius R, and slope S. We only need to enter the value for each hour according to the schedule that has been built. Finally, to obtain the discharge value, Q can be calculated using the formula area A times the volume V. Then, we will proceed to Fiza to plot the discharge graph against time for all 3 days.
Assalamualaikum warahmatullahi wabarakatuh. My name is Firza Amani binti Ainan. My metric number is CF240239. Once the data from the table has been collected, we can proceed to the next step, which is plotting the data. We need to plot the total flow versus time for 3 different days. For the data on 19 November, the time we select is from 12 am until 11 am, and for the total flow Q, we use the values obtained from the previous calculation. Then we plot the graph of Q versus T and insert it into Excel. For 26 November, the time range is the same from 12 am until 11 am. Follow the previously calculated values for Q and plot the graph for Q versus T as before, and this is the graph looks after plotting. Lastly, for 29 November, the time range is from 12 am until 6 pm. Follow the same step as before. For the unit hydrograph, we will use the straight line method because it is a simple way to separate base flow compared to other methods. So from graph total flow versus time, starting from the left point, which is constant, extend a straight line to the right. This step helps to determine the base flow value. To create the table, we need to include the columns for date, time, total flow, base flow, direct flow, and UH ordinate. The total flow column will show the flow values for each time. The base flow is determined by drawing a straight line to separate it from the rest of the flow. Direct flow is calculated by subtracting base flow from total flow. And finally, the UH ordinate is found by dividing direct flow by the run of depth. For the unit hydrograph ordinate, we need to calculate the total direct run of volume. To do this, multiply the total direct flow by 1 hour, then multiply by 60 minutes over 1 hour, and then by 60 seconds over 1 minute. The result will be in cubic meters. Next, calculate the run-off depth by dividing the total direct run of volume by the area in kilometer square, and then multiplying by 1 km over 1000 meter, multiple 1 km over 1000 meter, and the answer is in centimeter. After that, divide the direct flow value by the run-off depth to get the unit hydrograph ordinate, and finally plot the UH ordinate versus time. For the data on 26 November, we will follow the same step as described above. The total direct run of volume will get 24.23 multiple 10 the power of 6 meter cube, and the run-off depth is 180.82 centimeter. Then this is the graph UH ordinate. Same as before, for 29 November, total direct run of volume is 45 multiple 10 to the power of 6 meter cube and 335.82 cm for run of depth, and this is UH ordinate graph for this day.
Hi, my name is Umar from Haidil. My matrix number is CF240415. So today I'm going to talk about graph rainfall and discharge data, and I'll explain overall about it. First thing first, the day which is from the data is 1st of November 2024 until 30th of November 2024, and their water level, I get it from the info Banjir Malaysia. The rainfall also, I get it from the info Banjir Malaysia. So for this calculation, I'm just using a simple calculation, and the formula is Q, A, P, R, S, P, and V. Q is total flow, A is area, P is weighted perimeter, R is hydraulic radius, S is given 0.085, B is width, and velocity is V. So for the first calculation is area. Area I'm just using width multiplied by water level. So for the first column as example, as you can see, 123.8 multiplied by 7.22, and then you get 893.84. So for the first perimeter, in the same column, I'm using the width 123.8 plus 2 multiplied by water level 7.22, and then you get 138.24. And for the radius, it's just a simple area divided by P, perimeter, 893.84 divided by 138.24, and then you get the radius for the first column is 6.47. For the Manning equation is where you to find the total flow. To find total flow is using area multiplied by velocity. For the velocity, I'm using the 1 per n multiplied by r the power of 2 per 3 multiplied by s 1 per 2. So if you find the area and then you find velocity, and then you can get the total flow. For the first area, 893.84 multiplied by velocity for the first column is 20.24, and then you get 18,091.24. And then just using the same calculation for the next column and so on. And then I plot the graph rainfall and discharge versus day in the same section, and then you get it. That's all from me. Thank you.
Hi, my name is Muhammad Nazmi Reza bin Ahmad Hafiz, and my matrix number is CF240408. So, I will explain about the rational method. So, this is the map and evaluation profile of the Sungai Siput. So, the value of L, which is overland sheet flow path length, is 4,650 meter, which is 4.65 kilometer. And for S, which is slope of overland surface, is 0.085%. This is the method how to find the time concentration. So the land surface is average grass, which is our value of n is 0.045. So this is the formula. So the final answer is 131.58 minutes or 2 hours 11 minutes. So next we will find the average rainfall intensity. So this is the formula of average rainfall intensity. Okay, so 72.163 multiply 100 power of 0.184 per 0.81 plus 0.376 power of 0.900, we will get 144.42 millimeter per hour. So the final answer for average rainfall intensity is 144.42 millimeter per hour. So for the Q, which is peak flow, this is the formula how to find the peak flow. Okay, the formula is runoff coefficient multiply average rainfall intensity multiply cross section area per 360. So the final answer is 210.56 meter square per second. So our peak flow is 210.56 meter square per second.
Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Al-Hakim bin Pakana, and my matrix CF240305. And today I would like to continue the presentation with the Manning equation using the cross section, which is the cross section we have to divide for the three part, the upstream, middle stream, and the downstream. So using the Google Earth Pro, we can get the perimeter area and the slope, which is the perimeter, the value I get 34.2, the area 47.9, and the slope I get the 33.78. And I use the value of n 0.05, and the radius, which is area divide the perimeter, I get the value 1.69 and the value of Q 9549.11. So for the cross section and the middle stream, value of the perimeter I get 38.3, the area I get the 16.5, the value of the slope 11.33, and I use the value of n 0.05 and the radius 1.58 and the value of the Q 5645.67. Next, the last part of the cross section and the downstream, the perimeter of the river I get the value 23.5, the area I get the value 29.1, the value of the slope I get 10.18, and I use the value of n 0.05 and the radius the value 1.24 and the value of the Q 2143.28.
And the last one is conclusion. In conclusion, the hydrograph successfully analyzed the relationship between rainfall and stream flow. The hydrograph revealed key insight into peak discharge, lag time, and base flow, showing how the watershed respond to precipitation. These findings are crucial for flood prediction, stormwater management, and understanding watershed health. The project's result can inform future water resource management and urban planning efforts to mitigate flood risk and improve resilience to extreme weather events. So that's all from us, and thank you so much.